Hello everyone, in this video we are going to see a demonstration of our project. In the previous video we had seen how to create a new project in East Coast Studio and how to configure the stacks in East Coast Studio as well as the hardware configurations. So in this video now we can see the demonstration of our project. Okay, right now you are seeing the East Coast Studio allentry.c code. This is the actual logic code where the input logic works. Now we have to build this project. For building this project, let's press Ctrl plus B to build the project. You can see in the console window that there is 0 error and 0 warning. Now let's debug this. You have seen that an insect-like structure debug square wave. In that we have to debug. Press the debug. Now you can see target is connected. Now let's press resume button. Click once again. Now you see that in the same window running is seen in left side of the PC. So the actual code is running. So now let's move on to our configuration. So in the previous video we have seen that we have configured 4x4 keypad matrix along with the Renesas ARM Cortex M33 based Renesas microcontroller. For the serial monitoring purpose, we have configured Arduino Uno. So these are the connections we had made. We had configured a 4x4 keypad. In that we have configured 4 rows and 2 columns. And in that 4 rows, the 4 rows act as a output mode and 2 columns that act as a input mode. So we had configured input mode as an external interrupt. So in the previous video you can see that we had mentioned about how to configure the stacks external interrupts IRQ0 and IRQ1. So in that you can see that in the first number in this keypad indicates the first floor, and the second number in the keypad indicates second floor, fourth number indicates third floor, fifth number indicates fourth floor, and seventh number indicates final last floor, fifth floor. So we had configured the wires which is connected to the Renesas RA62, and for the UART purpose we had configured to make the baud rate equal. We had configured ground to ground connection. Also we are transmitting the information from Renesas. So we are made a connection from this is the transmitter pin, and it is going into the receiver of the Arduino Uno, and these two are the ground pins of both Renesas and the Arduino Uno. Okay, now in the Arduino Uno you can see that in the serial monitoring smart lift controller interrupt system ready. So actually we have configured in the 8051 microcontroller we can also able to configure the keypad matrix, but the only drawback is in the 8051 microcontroller it makes the decision based on continuous coding, which makes the system very less powerful. Also it consumes more power. So in that keypad by using the Renesas RA62 we had configured the 4x4 keypad matrix as external interrupt rather than continuous coding. Okay, now let's press the keys and let's see the output. While I am pressing one, you can see that person selected floor 1 and door opening and door closer, the elevator ready for the next request. We have configured floor 1 as 0th floor, which is ground floor. So how actually the signal is sending means, in that we had configured 4 rows and 2 columns. For the 4 rows we had made it as output mode. Also it is initially low, which indicates the ground, and the 2 columns which is input mode, which was VCC, or which was initially let's consider. So if I press, there is no path between the VCC and ground. So if I press 1, which indicates that means the VCC, there is a path for the VCC to travel, which will be indicating like person selected floor 1, like. Now let's press 5th floor, which we had configured as number 7. Now you can see that the elevator is moving from floor 1 to floor 5. So since we had pressed floor 5, the elevator will not stop between any floor. It just the door will be open on the 5th floor. Okay, now the elevator is ready for the next request. So let's now press directly the first floor. Now currently the lift is under 5th floor. Okay, then now we can see the scan algorithm that we have used in here. The scan algorithm indicates that if I press it, now the elevator is currently under the first floor, which is the ground floor, which we have configured. If I press the 5th floor, in between if I press the 4th, 3rd floor, then it will first I will press 5th floor, then followed by 4th floor, then followed by 3rd floor. Then it will understand that because of the scan algorithm, it will understand that even though I had pressed 5th floor as first and 4th floor as second and 3rd floor as last, but it will go to 3rd floor and open the elevator, then 4th floor, then there it will be open, and in the 5th floor it will be open. Let's see. This is the 5th floor, this is the 4th floor, and this is the 3rd floor. You can see clearly that the scan algorithm is working correctly. Now the lift is currently under first floor, the 5th floor. So now if I and the other way of scan algorithm is also valid. If I press the first floor, if I firstly press the first floor, then followed by some other floors, the scan algorithm will work correctly. Now currently the lift is under 5th floor. So according to the scan algorithm, if I press the first floor, then followed by 2nd floor, then followed by 3rd floor, the door will be opened on the 3rd floor, then followed by 2nd floor, then only 1st floor. That's implicit our scan algorithm. So now I am pressing this the 1st floor, and this 2nd floor, and this is 3rd floor. You can see that the scan algorithm is valid, and the scan algorithm and the printing of UART is also done using 8051, but the flow of how we are storing is only done using the Renesas RA62. This explicitly tells that why we are going for RA62 ARM Cortex M33 based, which has 200 MHz crystal, instead of going with 8-bit 8051 microcontroller. Here the scan algorithm and it all takes it all needs to be processed very quickly earlier, as well as it needs to slow in the UART. So this cannot be done using 8051 microcontroller. Thus we are going for RA62 ARM Cortex M33 based Renesas RA62 microcontroller. So that's all about our project. Thank you.